In the previous part, we discussed how to solve the online bipartite matching problem. And next, let's talk about a specific application of this problem, which is web advertising. And web advertising actually appears around the same time as the internet. And the initial form of web advertising is banner ads. As you can see here, this is a website, and these parts inside the red boxes are some example banner ads. So basically, popular websites will charge some amount of money for, let's say, 1,000 impressions of the ad. And an impression basically means that it shows the ad for once, right? And this is called CPM rate, or the cost per 1,000 impressions. And the letter M here, basically it's the Roman letter for 1,000. This is why it's called CPM. And this is actually a similar model to TV commercials or magazine advertisements. And in the early version of banner ads, it's actually untargeted ads. That means the same ads will be shown to all the different users. So usually this may result in very low click-through rates. Here, click-through rate means the probability of users will click some ads if it's shown that ad. So a low click-through rate usually it will usually means very low return on investment for the advertisers. So in this case, advertisers might not be happy about it, right? And this is why over the years, people and search engines or these websites will switch to a different mode, which is called demographically targeted. And usually what they do is that they will make the ads more targeted to the user. For example, they can show different ads to younger persons or elderlies. And unfortunately, this is not enough, because even if your ads are demographically targeted, users may still receive a large number of irrelevant ads. And this is why Overture introduced what we call performance-based advertising. And Overture is a search engine or search company later acquired by Yahoo. So basically, performance-based advertising works like this. The advertisers will first bid on some search keywords. And when someone searches for that keyword, the highest bidder's ad will be shown. And one key innovation of this performance-based advertising is that these advertisers is charged only if the ad is clicked on. So in this case, they don't have to worry about low click-through rates. And the similar model is adapted by Google with some changes around 2002, and it's called Adwords. And this is an example of what the ads in Google look like in the early stages in 2000, around that time. And so these are the actual search results, and on the side, Google has some ads shown here. And this is what the ads look like in Google nowadays. So if you search health insurance in Google now, you might probably get something like this. In the first few results are some ads from some health insurance company, and below it, there will be some actual search results. So this concept of performance-based advertising, it actually works very well, and has later become a multi-billion-dollar industry. And one interesting problem about performance-based advertising is what ads to show for a given query, right? So this is called the Adwords problem, and it will be the focus of today's lecture. For example, let's say that these four nodes on the left are no longer voids. They're actually some ads from some advertisers, and on the right we have, instead of girls, we have some queries that's appearing constantly. Then the problem is, if we're given one query, then what ads should we show for this query, right? So this is why we say that this problem is actually very related to the online bipartite matching problem. And another equally interesting problem is, if I'm an advertiser, what search terms should I bid on? And also, how much should I bid on these search terms? So this is also a very important problem, but it's not the focus of today's lecture. So formally, this AdWords problem, the setting is that we're given a set of bids by the advertisers for search queries. And we're also given a click-through rate for each advertiser query pair. So we know exactly how large is the probability that these some ads will get clicked if it's shown to the users. And we're also given a budget from each advertiser. Say for 1 month, this advertiser will only have a budget of 1,000. So once this budget is exhausted, then the search engine will no longer show ads from this advertiser. And we're also given a limit on the number of ads to be displayed with each search query. So because you have only so much space in the front page of your search engine, so maybe you have 1 or 2 or 3 slots where you can put in your ads, right? And given all this, a algorithm will try to respond to each search query with a set of advertisers or ads such that the size of the set is no larger than the limit on the number of ads per query. So it should not be larger than 1 or 2 or 3. And each advertiser, we need to make sure that each advertiser has bid on the search query. Otherwise, it will not show the corresponding ads. And we also need to make sure that each advertiser has enough budget left to pay for the ad if it's clicked upon. And the problem setting is that we will have a stream of queries arrive at the search engine. Let's call them Q1, Q2, etc., etc. And we have several advertisers bid on each query. And we query QI arrives, and the search engine must pick a subset of advertisers whose ads are shown. So this is like one girl on the right will appear with some preferences, and we need to decide what's the girl we need to pick to match these girls, right? So in this case, the boys are the ads and the girls are the queries. So the goal of this AdWords algorithm is to maximize the search engine's revenues. And the simple solution, as we will discuss later, is that instead of the raw bids, we will use the expected revenue per click. So basically, this will be the bid, the price, times the CTR or click-through. And clearly, we also need an online algorithm for this. So concretely, let's say that we have 3 advertisers, and each advertiser has a certain bid. For example, for the first advertiser, the bid is $1, and the second advertiser bid is 0.75, and the third one is 0.5. And the original version of performance-based advertising from Overture, it basically will choose the advertiser based on the bid alone. So the higher the bid is, the more probable it's gonna get picked. For example, if there's only 1 slot for the query, then Overture will probably just choose advertiser A because advertiser A has the highest bid. And the innovation of Google's AdWords is that because you want to actually maximize the expected revenue, right? So if you only consider the bid, it's actually not the optimal solution. This is why they also consider the click-through rate, or CTR. Again, so click-through rate is a probability that this ad will be clicked by users if it's shown to the users. So as you can see that this first advertiser actually has a relatively low click-through rate. And the second advertiser, although this advertiser has a relatively low bid, but the click-through rate is significantly higher. And if we compute the expected revenue as the bid times the CTR, we'll get something like this. So basically, the expected revenue for of showing the ads from advertiser A will be just 1 cent, and the expected revenue for B is 1.5, and for C the expected revenue will be 1.125. So as you can see, in this case, although this advertiser A has the highest bid, it turns out it has actually the lowest expected revenue. So if we sort them, sort this 3 advertiser by the expected revenue, we will have something like this. So clearly, if you have only one slot, you will prefer to show the ads from advertiser B as opposed to C or A, right? And there are actually 2 complications in web advertising. The first one would be the budget, as I mentioned before, because each advertiser has a limited budget, and search engine must guarantee that this advertiser will not be charged more than their daily budget or monthly budget. And the second problem is the CTR, which we assume that is given. In reality, this CTR for the ad is actually unknown. Now, this poses extra challenges for us. So basically, for this second problem, each ad has a different likelihood of being clicked, right? This is different CTR. For example, advertiser 1, although it bids $2, but the click probability for this ad is only 0.1. And advertiser 2 might bid a little bit less, $1, but the click probability for this advertiser will be 0.5, which is significantly higher. So these are different click probability. And in reality, we actually don't know for sure how high this click probability is. And usually this click probability or click-through rate, it should be measured historically. For example, for some ad, you can show this ad for 1,000 times and just count the number of times that this ad got clicked by user, and you have the percentage, right? And besides this, we have one additional very difficult problem. This is what we usually call exploitation trade-off. So basically, the problem is that since we have so many new ads appearing every day by some new advertisers, new companies, so should we keep showing older ads for which we have relatively good estimates of click-through rate? Or should we show a brand new ad to get a better sense or better estimate of its click-through rate? The problem of using the first option is that if some new ads actually has much higher click-through rate, and you choose to ignore them and choose not to show them, then you might be missing the opportunity of making a lot of money by showing this new ad, right? And alternatively, another problem of choosing the second option is that in the opposite, let's say that some brand new app actually has very low click-through rate, right? And if you show this brand new app and actually by showing them actually do not get much, then in this case you might as well just show some old ads that you have better estimate of click-through rates. So this is a very difficult problem to actually trade off between exploration and exploitation.